Okay, here we are back again for another mostly unscripted demo. That is to say, I don't know exactly what I'm going to say, but this time I've actually prepared files to save a little bit of typing, and so I can just explain the files rather than making you watch me type. And also because there's a lot of attribute names which I'm bound to get wrong, and we don't need to see tons of my syntax errors. So when we last left, I was going over the like constructs and talking about how they came to be because we wanted to make it a lot easier to write tests. And it's often difficult to test your stored procedures because, well, first you have the problem of testing the code that uses the stored procedures to get data and do stuff. So we wanted to be able to mock result sets, and so there were some helpers for creating mock result sets without having to actually go and create whatever schema. But then you also want to test the stored procs themselves. They may have control flow logic, or maybe they just have a query, but you want to experiment with the query and make sure it works right in all of the various different conditions, and that you can verify what the results are and that the results are what you intended them to be. So we created some facilities for that. We're about to delve into an area where I should give a shout out to a couple of my colleagues, Zybo and Raul, who did basically all of the coding for test helpers. This is an area that I've only touched very, very lightly, and I've just kind of got to watch it in somewhat awe and delight as it's evolved a little bit. And as you'll see, it's one of the areas that's a bit meta, and this is a pattern in SQL that repeats itself. So without further ado, let me just jump right into some source code, and we'll see what the heck I'm talking about with these test helpers. So I've made a bunch of files called A, B, C, D, E, F, so I can remember them easily. And this is the first one. It's a very, very simple example. There's a table called foo. It's got an ID and a name. So, that's pretty easy. The ID is the primary key. Doesn't get much simpler than this. And you can guess as this example expands, it's going to get, more exciting with more names. Okay, and this is the first instance where we're seeing an attribute. Okay, so this is an example of an attribute. The attribute's name is SQL autotest, and the value is dummy table. And you can see that it's parenthesized like this. That's because it's actually a list of potential auto test types you want. And one of the nice things about SQL attributes is they nest like this. So you can, you could in principle have attributes that look kind of like that, with arbitrary nesting. And that's kind of cool. Because you can express a lot. In fact, you can express an arbitrary Lisp program inside of a SQL attribute, and as a consequence, they're extremely expressive should you need them to be. Although in most cases they're super simple. In this case, we'll see it's just mostly a list of the kinds of auto test things you want. So here's the thing we're testing, which I've creatively called the subject. Okay, this is the subject under test. And it's the simplest thing you could possibly imagine, select star from foo. So imagine we were going to test this. Now, in reality, this would be from, where, whatever, having, oh my God, and probably some arguments here, that fed into this, and you'd want to test it with a variety of things. So you can imagine wanting to set this up in such a way that you could, make this test go. Okay, so first, let's go back and remember what was going on with the mocks we did last time. Okay, so I'm gonna walk you through how we can do the mocking automatically, and so this next bit will be sort of what you get if you just do dummy table. Okay, so to compile this, I'm gonna just say out/SQL -in a. This time I'm gonna say result type test helpers. Okay, and then I'm gonna do cogen a test.sql. Okay, great. Now also I could have done this, right? -in a cg a.h a.c. So this is the actual code for your thing. Okay, remember the result set thing. This is the code that's generated. All the metadata, same as the stuff we talked about last time. There's the getters. There's the struct thing, and okay, right? So this is going to create a bunch of code. Now, but if you want to test this, you're going to need to do some setup. So let's look at what we get in a test.sql. Okay. Notice we did not get C. We got more CQL, which we could then compile. Okay, so here's a redeclaration of the subject that matches. Okay, that's important. So you get a bona fide correct declaration for your procedure. Okay, and so that means we don't have to compile your procedure, right? No matter what the build environment is for your procedure, or whatever pre-processing weirdness you had, we know what the net definition was, so we emit that right here, okay? And we don't emit the body of the procedure, just a declaration. Okay, so in principle we could call it, but in practice we don't. Okay, and then we get two procedures for free, okay? Open the subject and close the subject, okay? And the subject comes from, obviously, this name, okay? So it goes there. And then it does create temp table, test the subject, okay? Like the subject. And so this is going to make a temp table just like we made last time. Now notice what we've done here. We use the like construct not on a table, but on a procedure. In fact, it's the important thing is it's the result shape of the procedure. So it's this bit, right? The bit that's actually there. The arguments of the procedure are irrelevant because what we're trying to do is create a mock for what the procedure might return. Okay, this is the mock part, right? So we're trying to mock the result set, just like we did in the last thing, only now we're doing it automatically. So remember, we wrote this code, or code very much like this. I was a little bit abbreviated last time. And so this makes the table and drops the table, and so you get those procedures for free. You call them, and you get a table of the right shape. And of course, this like expands to all the columns that are in the return type of that. So we're going to get, this big thing right here. Whatever this is, we're going to get that. Okay, and so it doesn't matter what you return, you're going to get a table that matches that. So for giggles, and I'm not going to do this every time, but now we could do this /CQL -in, because this is what you have to do. Now you compile that atest.sql -cg atest.h atest.c. Well, I did .cc, but it doesn't matter. atest.cc. Okay, now we'll take a quick look at this, and let me scroll around a little bit. Okay, so already you can see create test the subject was expanded into ID and name. Okay, so this exactly matches what the procedure is going to return, right? Which is perfect. Okay, and no matter what it did, no matter how you computed the shape, whatever the result type was, this table is going to match that because of the symbolic naming. So importantly, those like things, they can refer to three important kinds of things. Well, several, more than three, I guess. Okay, let's look at atest.sql again. Okay, in this like construct, there, okay, the subject, whatever you put here, it can be the name of a table, the name of a view. The table has a shape, a view has a shape. It can be the name of a cursor that you previously defined that has a shape. Or it can be the name of a procedure that has a result set shape. And that turns out to be a really good way actually to just create arbitrary shapes that you might want to use. In some sense, this is kind of like a type def, right? I mean, you could imagine making a procedure with just some name that you have no intention of ever creating, goo, okay? And then you can say like goo. You could even stick this in a header file somewhere. And that's a type def. I mean, basically, because there never will be a goo. All you can ever do with goo is use it as a shape. And you can use it anywhere a shape is allowed. So, and what's nice about that form is no one will ever be confused thinking, wait, is someone going to make that table? Does that table exist? Do I have to drop it? No, especially if you give a name like, goo type or something, right, to make it even more clear, but or with a good naming convention. But anyway, you get the idea. So procedure results, which is super important to enable this code pattern, and cursors, views, and tables. And those are the things that have a shape. And if anything else came along that had a name and a shape, well, that would soon become legal as well, because I'm sure it would be useful. All right, so that's A. Let's look at B. Moving on to B. Okay, so we added a new one, dummy table, dummy insert. Okay, I'm just building these up, and that's why I typed these in advance, and I didn't want to keep getting this wrong or forgetting the parens. Okay, so very, very simple. And this has no hope of compiling because I forgot the definition of foo. So apparently I'm going to be typing after all. So much for preparing, Rico. Okay, there, that should compile. So I'm going to do this again, only this time it's going to be B, and B. Probably could have typed this faster. Okay, so obviously it compiled now. It had to be semantically analyzed to do this. So if there were compilation errors, you would have seen them. You can't, it already has to pass. You're just getting a different style of output. Okay, so open and close we had before. Now we get this. Okay, you can ask for it or not. If you want it, ask for it. This gives you a procedure that does an insert, and its arguments are like the subject. Okay, and we're going to do insert into blah blah, test the subject from arguments. Okay, so obviously that's going to match, right? We created the table using that shape. The arguments match that shape, and we're inserting into the table from that shape. So we just out of thin air, without even knowing the shape of the beauty of it is practically hard coded, right? You can see how this is, you know, just boilerplate with the name being swapped in. So simple. So without even knowing the shape or caring what the shape is, you can make a procedure that takes that shape and inserts that shape into the temporary table. Great. Okay. So if you like, we can compile that, but it's going to be ultra boring. Okay, we'll do one more. I won't keep doing these all day long though, because it's just going to make this run on a little longer. So in btest.sql regular CG btest.h btest.c, and what did I do wrong? btest.sql, there you go. Okay, so looking at this, okay, there's our insert. All right, there it is, insert test ID name values question question. Okay, and you can see, well, it's actually easier to just read. This is the expanded SQL, right? That's what actually got compiled. ID integer not null, name text, exactly what we expected. The columns are ID and name. The values are ID underscore and name underscore, and this is this canonical form to prepare and bind, right? However many args there are, boom, they get bound. Okay, so the nice thing about doing this in two passes is the code generation is much simpler. It does complicate your build a little bit, right? Because when you're doing test generation, you do two CQL invocations. Okay, great. So let's look at C. Okay, this time I remembered foo and I added bar. Okay, and so here I have dummy table, dummy insert, dummy select, and dummy result set. Okay, so we added two new ones, dummy select and dummy result set. Let's see what those do. And the subject otherwise looks the same, except for now it's select star from bar. So we're getting these two. You know, and actually I'm not even that excited about that. How about I make it a little bit more complicated, going off script already. Okay, so how about bar.star, foo.star, no, I can't do that, foo.id, comma, foo.name as n1, and bar.id as, no, I don't even want bar ID. I just want bar.name from bar inner join foo on bar.id equals foo.id. How about that? Okay, so there, I actually did a join and I pulled together some columns. Okay, and now I'm getting both different names, bar.name as bar name. Okay, great. All right, so here we are. /CQL dash in C. Okay, good. So it did in fact parse RT test helpers CG-SQL test.sql. Okay, oh, semantic analysis didn't happen. Okay, what do we got on line 14? Oh my goodness, that's what I get for going off script. Okay, I was hoping to avoid all of this, but no, I had to be tempted. Okay, what do we got? Bar.id, foo.name as n1, bar.name as bar name, from bar inner join foo on bar.id equals foo.id. Boy, that looks right to me. Okay, as N1. Okay, so sometimes when I don't know where the error is, I do this, splitting the statement onto many lines so that the error will be more specific. Name not found, name, okay, on line 16. Oh, okay, cripes. Okay, I didn't have to do this. I thought they were both name. One is name and the other's data. Okay, so I could have done this, bar.star. I'll just do that. Okay, great. Okay, I thought I was going to have two things called names, so I aliased them, but I'm not going to have two because I have name and text. And so I also want, no, I want foo.name, foo.name and bar.data. There we go. I don't want bar.star. Okay, great. Being out. Okay, oh, crap. Expecting semicolon 14. From bar inner join. Oh my goodness. From bar inner join. Are we having fun watching me fumble this? Okay, great. I'm not typing in those files anymore. I'm done typing. Okay, open, close, insert. We already saw all these. Here we are, select. Okay, all we did was add this thing, select star from test the subject, because you're probably going to want that. And this one. Okay, now here's what's interesting. The reason I did all that was to show you that this changes. Okay, so the shape of what subjects are returning just changed, and you know, we sort of don't care, right? This declaration changed, and now there's name and data. Okay, so suddenly the temp table is going to have a different shape, and closing it, of course, the shape doesn't matter. Inserting it, we get an extra arg here, and we're going to insert that extra arg there, and the extra column name is going to be mentioned automatically. Boy, there's lots of cool stuff here. Here we're going to select all the columns like usual. And here, this is, and I haven't shown you the out form yet, but basically what this is doing is saying, if you want to simulate a particular single row result set, okay, I don't want it the temporary table. I just need one row in the result set. You can pass the args, okay, so here's everything you want in the row. Then it says make a cursor that is the right shape, okay. So cursor like the subject, okay, so that's a cursor with all those fields. This is a so-called value cursor because there's no SQL statement associated with it, so you can't really step it forward, but you can stuff values into it from the arguments, just like this. So this basically makes a row of the correct shape, okay, without using the database at all, and then emits that row as if it were a select, okay, but it's a single row. So this gives us one row back, which can be very handy because lots of times you just want one fake row like this and one fake row like that, and you don't want to do open, close, whatever. Okay, so just another little different helper. But again, look at how powerful this is. Like this from arguments appears in lots of different places, and this is just, you know, more of that syntactic sugar. It could have been fetch cursor, you know, whatever the columns are, ID, name, data, from, oh my goodness, you know, from ID underscore name underscore data underscore, and then over here we could have expanded all this, but like, you know, that's going to be a mess, right? You're just going to get that wrong, and the columns could be in the wrong order, and what if there's 75 of them, and you know, what if somebody did this data name, you know. Okay, these are kind of my nightmare bugs, right? Like someone could do that. Those types are compatible, right? Let's go, like now you swap the name, like who needs that aggravation? So this right here, it's much more bulletproof, very simple. You know it's going to match, you know the types are going to be right, you know it's going to be maintained. And if there's any tests that are using this, if you add a new column, when they call this helper, they're going to get a nice clean error because the number of args is not going to match. And so you're going to easily find all the ones that are missing the args and just fix them up, add the new column, or if you delete a column, there'll be too many args. So it just all works out really nice. Okay, so those are the simple ones. Okay, so what are we up to C? Let's look at D. Okay, so now this one has all of them, plus one more. Dummy table, dummy insert, dummy select, dummy result set, and dummy test. This one is, these ones are very straightforward, and these are about mocking result sets. Okay, this one is about creating mock data so that the real stored proc can run. And it does piles of stuff for you, and so we'll take a look at that. We have the same setup here with foo and bar. Okay, and we just did select star from bar. It doesn't really matter what we do. As we see, I'm going to complicate this up a little bit as we go forward, but you can already see I could have put the funky join here, and that would work just fine. So let's have a look at what happens here. Okay, so we are on D, right? Okay, so /CQL -- in, I just cursor up. It's right there. Okay, D test. And D, yeah, D, okay, D test.sql. Okay, so what do we got? Oh, we got our little dead beef signature. By the way, this is so if you use sign source, it'll edit that. So some people like to use sign source, so you get free dead beef. Okay, so here's our subject like usual: open, close, insert, generate. Okay, we already saw all these. I'm just going to even, for ease of screen, I'm just going to delete those. Okay, so these are the new ones. So let's have a look at this. Wow, this is already cool. Okay, test _ the subject _ create tables. Okay, so you can already see how this procedure name was made. Okay, so it gets a test _ prefix, and this is for creating the tables. And what does it do? It creates the tables. These are the tables that you're going to need to use that procedure. Now, what's beautiful is it does not matter where they were declared or how they were declared or what .h file you pound included or whatever. A lot of times you get schema from weird places. It's very normal to pound include your schema when you're defining your stored procs. This gives you an inline definition of exactly the tables that it needs. Okay, and it uses foo and bar. And notice it gets a foo even though you only referred to bar, or was it the other way around? Yeah, it's bar refers to foo. So we selected from bar, we implicitly got foo, and the reason we implicitly got foo is because there's this references foo ID. So you can't insert rows into bar without also inserting rows into foo. And so if you want a fake bar, you got a fake foo. Okay, so this makes our tables. And this does populate tables. Okay, so this is some helper code that puts some data in there. Okay, and remember dummy nullables, dummy defaults, and dummy seed? Boy, they're your friend. Okay, so here's two rows, some with nulls and defaults, some without. Okay, so you get a minimum of 2 rows, 1, 2, 1, 2. Okay, and we'll see we can actually be more flexible than that if we want. Okay, so we put some rows into foo, and then because of that, we put some rows into bar. Notice that the ID was specified explicitly. Okay, that's super important because there's a foreign key. So the bar IDs match the foo IDs that we created. Okay, so this one corresponds to that, and this one corresponds to that. Okay, and that will be preserved. Great. What else do we get? Drop tables. Okay, drop table if exists foo, drop table. So this is what you do to clean up after your test is run. Of course, you could insert your own additional data too. There's no reason why you can't add more data with manual code. But as we'll see, there's ways to automate some of that too. Okay, great. So test the subject, read foo. Okay, that's just select star from foo. Great. Okay, so this gives us what's in our temporary tables. And actually there's 2 of them. So we can go and look at what was produced if we need that. So we get 2 helpers for that. And that's it. That's what you get in the basic stuff. So you can see very easily if you wanted to test the subject procedure. Remember, this was all about testing the subject. You could call this to create your tables, then call this to seed the data, maybe add some data or mutate it after that if you wanted. Then when you were done, you could drop the tables here. And if you wanted to snoop what was created in the 2 tables that are necessary, we give you these 2 convenient little helpers for that. Of course, you don't really need those so very much, but whatever, they're straightforward, they're there. And so it's just one less thing you have to write. And this turns out this comes up often enough that it just, saves you a little bit of grief. Okay, perfect. So is that it? I feel like Rompopeel. Now how much would you pay? Okay, let's look at E. Okay, because life is frequently more complicated than just tables. So here's foo and bar, okay? And here's the usual relationship. Oh, foo has an index and bar has an index. Those might be important. Maybe performance matters. Maybe you're going to be checking the query plans. Maybe I don't know what you're doing. Oh, look, there's a trigger on foo, okay? So that could be important. You know, maybe it's going to do important side effects that you want to check. Okay, clearly this is a bogus trigger. Okay, so right, so not a real trigger, but importantly, that you can have the trigger installed. Oh, look, here's a view. Okay, right. So we have a view, and it's doing select star from bar. And now look at our test case. Holy moly, we're doing select star from v. Okay, so the subject only references v directly. Okay, and to make the output a little bit simpler, I'm going to get rid of these ones that we've looked at so many times because they're going to be exactly the same. And I'm just going to keep dummy test. And look at that. We also have some of our meta syntax. Okay, we have bar data plug. Okay, so this is saying in the bar table, for the data column, I want the value plug. Did I mention these could be arbitrarily complicated? So there's basically data initializers right here in line in the auto test attribute if you want to specify some of your sample data, because maybe some of your sample data is super important, and there it is declaratively specified in your thing. Okay, so let's save that. Remember I said I wasn't going to edit anything because I was making typos and that was slowing us down, and there I go, just editing again. But I'm sure this time it's going to be perfectly successful. Okay, good. etest.sql. What did we get this time? Wow. Create tables. Okay, inside of create tables we also create the view. Okay, so create tables maybe should have been called create tables and views. Okay, there's a separate procedure for creating triggers because you may or may not want them for any particular test. Okay, so if you want your triggers, call create triggers. And you might want to do the triggers before, after you populate, you might, you know, for various different reasons. So the triggers are done separately. Okay, and there we go. And populate tables, and drop triggers. And here we are, create indices, okay, and drop indices. Okay, so again, you might want your indices, you might not want your indices, you might want to observe the difference. So you can do a full setup really simple. Create tables, create triggers, create indices, and you're in business. And the beauty of it is you didn't have to know all this stuff. Like no matter where that trigger came from, maybe you didn't even know that trigger even existed. It's buried in the schema somewhere. Don't worry, it's going to compute the transitive closure of, you know, what you referred, and then what that refers to, including the indices and the triggers. And if the triggers could refer to more tables, which could bring in those tables. So you get all the stuff you get, and magically you get this whole lovely little procedure. Okay, so here we have some helper procedures, right? To read foo and read bar and read v, okay? And v is the view here. So again, you know, those could be useful to you in your in the context of writing your tests. It's only test code anyway, so whatever. If you have a little bit of extra fat in your tested code, you know, that's just fine. Okay, so you get a lot here. Look at that. I mean, both tables populated plus the view, okay, is created. So what's perfect about that is, see, you need that view to be created so that your procedure can successfully run. And that means you could run your procedure sort of in its own unit test environment outside of your actual application. Your app might have a very complicated schema deployment strategy and whatnot. You don't need any of that for your unit test because you're going to get exactly the schema you need for your procedure right there in your code, and you can just call it and away you go. Okay, perfect. So I'm not going to compile this, but you already know what this would compile into. This is like, you know, this is CQL exec a string, CQL exec a string, CQL exec a string. You know, all of these are pretty much really totally straightforward bindings. You know, here these are even constants, right? Here there would be a binding for seed. There's the implicit seed variable. So this would be prepare, bind, and step, prepare, bind, and step, prepare, bind, and step, prepare, bind, and step. You get the idea. Okay, so super cool. And it doesn't matter what the columns are. If you add more columns, it still works. You know, the combination of dummy nullables and dummy defaults means that this code is going to work because it's going to fill in all the extra columns that you happen to be missing. You're going to get a dummy piece of text. And if you want some text, You can specify some or some fraction of the values for some fraction of the tables, and you get those. So here there was one sample value for bar, and so that was used in lieu of the automatically generated one. And then there's the second one. Okay, so looking at this, looking at one more. Here's F. Okay, and this one I'm going to do the same simplification here, just to keep the output code a little bit smaller. Okay, this is exactly the same. In fact, I don't think I even need this. You know, I'm gonna just to keep the code simpler. I'm going to get rid of that. I'll keep the views and the tables. Okay. So what's the difference? I changed the schema just a tiny bit. So here's bar has data 1 and data 2 now. And so I said for bar data 1 and data 2, I want these two columns. X, Y, I want these two data. Right? And we could have done a bunch of these actually. You could do any number of rows. In fact, okay, here we go. Let me do this much first before I go trying to break the thing and get myself into trouble. Okay, so here's that and this. Okay, and this will be super similar to what we just saw. Yeah, super similar. Okay, there's our table view. Okay, there's no triggers, so we won't have that, and we get our usual populator. Okay, and this time we have X, Y, Z, Z, Y, and plug. You know, so you're ready to begin your journey into Colossal Cave. And drop tables as usual, read foo, read bar, read v. Okay, so lots of cool helpers. Let me do one little change. Okay, you can do several pieces of data if you need. So for instance, you could do, I don't know, X, Y. Okay, perfect. Okay, so now we have, you know, another pair. And that's not going to be all that remarkable. Okay, so there we are. You know, now we have also the values X, Y, you know, with another ID. Okay, but here, let's see how exciting this is. Let's do one more. Okay, there's a reason I'm wanting to do one more. All right, we'll do one more. And probably if we were clever, we would have, you know, written this like this. Because white space is not really relevant. And now I'm using tabs all over the place. Okay. Here I'll just A, B, C, D. A, B, C, D. Okay, great. So there, I added some more data. Okay, so super exciting. Here, just to even make it more clear what's going on. You know, this goes with this. And this goes with this. And one of these goes with bar. It's the table, so really I should do like that. Okay. There. And you could do sample data for more than one table if you wanted. Okay. So this is also a list. Oh, that's not where I expected that to be. Attribute. That one goes with the attribute. That one goes with this list. Okay, I see what's going on. Oops. Okay, here. I'll do the last two together because we did the attribute. We did the attribute and the auto test on one line. Okay, so now it should be a little bit more obvious what's going on. These are the columns, those are the values. Great. Okay, and out. Okay, ftest.sql. Okay, so there you have it. Okay, and this is actually not going to work. Okay, so I was hoping to demonstrate that we did a clever thing, but we actually don't do the clever thing that I was hoping to demonstrate. So now I have to open a bug instead. Okay, so there should have been more values here because we added 5. So 2 values in the base table will not do the job. We also need 3, 4, 5 here, if you get the idea. Okay, so these are going to fail. So yeah, so that bug will be fixed soon, and then we won't have that bug anymore because we need to have at least as many values here as we have there. We did, you know, assign the IDs in the ordinal kind of way to make it so that the conflicts would work right, but the base table just didn't get its values. Okay, great. There you go. Unscripted demo, finding bugs while you wait. Suffice to say, this will be pretty straightforward to fix, but a little bit of logic will be needed to make sure that we have this right. And obviously this will be like this, right? Same as the others. Yeah. Okay, great. So that's all I've got, and now I get to fix a bug. Huzzah! Thanks for listening. Next time, I think we'll talk about schema generation, because now we've been exposed to sort of the meta nature where CQL generates more CQL. And the first place that happened was when we started using CQL to generate schema creation and management scripts. So we'll talk about those when next we meet.